Okay, hello everybody. Just minimize my thing here. Well, first off, I'd like to thank Vatical for even doing this, and Daniel for organizing things. Like he said, we're a small company, Geminos. We've got started a couple of years ago, and we're really focused on causal science, kind of what Judea Pearl's put together. But again, just kind of back to the Vatical side, like this community really is one of those unique, small, powerfully intelligent communities that seems to have attracted a really interesting group of people working on some really interesting problems. So just the fact that Vatical's really open to connecting us all together and like obviously making a big investment in terms of energy into setting these things up. Like as a small company, we love it because we have a chance to show what we're up to. But also just we get so much out of it. Like, I just started learning this stuff in December. I think I watched one of the first one of the first videos showing how to use Vatical and get going with it. So I kind of give you an idea of what we're here to talk about today. We're a company that's working on a tool that's allowing us to build causal solutions. And I'll explain what all of that means. But under the hoods of a causal solution, we believe there's a knowledge graph and a causal graph or a causal diagram. There's a guy, and I'll get into what all of this means in a second, but I'm going to show you a demo of this thing working. Like we've got pieces of it coming together. And a big part of this is how do we build solutions so that we can have our persistent store of all of this information on these relationships in an actual graph, something that can be persisted in a graph. And we're using TypeDB for that. So let me give you just a quick run through what this presentation is going to cover. Really three things: who we are, what we do, and how we do it. I'm going to try to keep it simple. I don't know if this is going to last an hour, but I'll show you sort of where we are today. And again, this is a work in progress. This isn't something that's 100% ready, but we're fleshing out some ideas. There was a really interesting question this morning posted on the Discord server asking about why something didn't do something in the solution that we have. And it's like a lot of these answers right now we're kind of figuring out what's the best way to approach this solution. So we're at the point where we're close to being able to do some beta testing, just to get a few people on it, find out where the problems are. So that's kind of where we are in the journey. But let's start up with who we are. So I'll go to the next slide. I don't have a lot of slides, but I'll go through a few of them just to set the context. So there's four people I'll talk about in the company. There's Stuart, who's the CEO of our company, and he's one of these entrepreneurs who's managed to successfully open and start and run a lot of companies. And he created a technology called Data Allegro a while ago that was acquired by Microsoft. So Stuart's got experience building modeling tools. He's done one of them before and sold it to Microsoft. Jerry, our CTO, one of those people that just seems to know every possible thing there is about the open source world and how it all works and how things fit together. His background is Internet of Things. He really understands how you can wire together all of these sensors in the world that we live in back into a compute infrastructure. And this is going to become important because when you're doing causality, you're really measuring what's happening in the world, and you're trying to understand what are the events that are happening that are causing something else to happen. And a lot of times these events are measured by sensors, or these causes are measured by sensors. So we'll dig into that. Hubbard is our wonderful vice president of business development. He's making sure we're talking to the right people. And so if you really believe there's an opportunity for us to work together, Hubbard's a great person to talk to. He understands a bigger picture of how individuals can come together and build things. My background's quite different. I did oil and gas for 18 years. So I ran Chevron's sort of their IT development shop for drilling in a worldwide sense. So I've got a lot of experience with big companies and the problems they face and how they face them, risk management, how they deal with that. So that's enough about us. We've been around for a while. None of us are young, but hopefully we have some ideas yet to contribute. And case in point, here's the man himself, Judea Pearl. He's the father, really, of cognitive causation. He's one that invented Bayesian networks, or not invented them, but he basically popularized the techniques of Bayesian inference networks, which is really a lot of the algorithms, the underlying mathematics behind deep learning infrastructures. And recently he's written this book, quite popular right now, called The Book of Why. He's a professor at UCLA. He's an academic, and a lot of the work in the Book of Why tends to focus on cause and effect and how you bring causal science into research, how you can take a problem, break it down, understand what's causing what and what types of things are interfering with what you're trying to measure. So there's a whole mathematics behind this, but the general idea is data science today. And I've also had 5 years in another company that did graphs, but data science today, there's a bit of a problem. There's correlation. A lot of the data scientists don't have a lot of experience. So a lot of what's happening is there's a lot of people looking at data, looking for correlations and using that to try to solve a problem and not actually understanding what are the factors that really are important and which ones aren't. It's very unexplainable. So one of the things that causal science is addressing is the explainability side of data science, so that when you come up with a solution, there's a chain of reasoning that a person can follow to understand, okay, here's why things are happening. That's why he's called it the Book of Why. So that's sort of the frame for it. But causality itself is something that's just taken off. Like, how many people are on this call? There's 40 people on this call, which is shocking to me, because I think there's a lot of interest in causality right now. I attended this Harvard class recently online. I'm not a Harvard graduate myself. I went to UBC here in Canada, but they had this online class and there were 60,000 people that signed up for it on causality. So there's interest out there. If you go on, just Google like causality Facebook, causality Lyft, causality Netflix. And Lyft, actually, the one that I watched recently, has a great explanation of how they're using causality to figure out which driver is closest and how they should be doing their dispatching. So it's using some of these principles. A lot of the big companies seem to be really interested in this. There's some belief out there that this is the next step towards artificial general intelligence. That's beyond my level of understanding, but I think we can do some really interesting things with causality in order to move us closer. Maybe not general intelligence, but I think we can make a lot of these solutions a lot more intelligent by adding a layer of causality to it. And I'll show you how to do this. And we're building a tool to help you do that. So we want to solve these problems, but in order to solve them, we also need a tool that we can use and a template that we can use with businesses to solve this, because these concepts really aren't that complicated. So let's just look at data science, but we'll look at it from the perspective of a causal lens. So data science, there's a lot of curve fitting going on. That seems to be 90% of the work out there, is find something you're trying to predict, find a bunch of variables that seem to predict it, and find the curves and then build probabilistic forecasting models based on it. One of the problems with data science is you can't figure out what's correlated and what's causing something. There's techniques, SHAP values, looking at what's going on, but correlation and causation are very different things. I think everybody, at least my generation, learned correlation is not causation in high school, but that's not always right. Sometimes it's correlated and it is the cause, but it doesn't mean it's always the cause. So this causal science is saying, let's look at what's actually causing it. And it's sometimes a challenge to meet business needs. Like my background, oil and gas, I'm used to working with people that don't know a lot about technology, but need it to run their business. And I think we lose them a lot with the data science discussions, because we tend to talk about algorithms a lot more than we talk about why we're doing something or what's causing it. Like we did one project back in the day where we paid a group of people to come up with why something's costing a lot of money. Why an oil well, for example, is costing a lot of money. What's causing it? It turns out it's the depth of the well is why it's like, well, that's not the cause of it. That's correlated to it, right? The depth of the well is correlated to the cost, but it's not driving the cost. It's just part of it. So what causal science is saying, well, let's start looking at the events. What are the things that affect the business? What are things that are happening in the world that we can measure? And we can start figuring out like chains of events. So if they start thinking about LSTMs and how do you find sets of events that happen commonly? Are there causal chains that can be discovered if we think about the world in terms of these causal events? So we're focusing on these chains of events. They're leading to some kind of outcome. So the example I'm going to walk through today is this example of customer churn for a 3PL. If you don't know what a 3PL is, it's a third-party logistics. So it's someone who's shipping goods on behalf of other companies. And some of the customers are leaving and some of them are staying, and they're saying, well, why are they leaving? So we'll use that as our example as we go through this today. So it's not like no more monolithic algorithms. We're not putting a bunch of data into a box and saying, here's the answer. There's a step ahead of that. So it is a natural extension of a knowledge model. And this is what the talk's sort of about today. I'm going to focus on the knowledge model that we built for it and the corresponding causal model and why you need a causal model that informs the knowledge model. And I'll show you what that looks like. We've implemented this. The world is microservices. Everything now is implemented as microservice that can be deployed through Docker and Kubernetes. It's what it looks like is happening. So the solution we're building is really true to that. And it's also using as many open source tools as we can, because frankly, that's the way to build solutions today. Don't go and build your own graph, find one that works. Don't go and build your own modeling tool from scratch, find one that's pretty close and modify it. So that's how we're approaching this, is how do we take a set of tools that we know already work, we know already scale, modify them and integrate them together so that we have something that people can use and we can modify it. And we don't have to support this entire stack. It makes life a lot easier. And then of course it's underpinned by the causal calculus. So we're not going to write. I had a few questions in the past, like, well, how do you do the calculus? Well, there's existing packages out there that we can integrate. So there's Python packages, there's R packages, there's Java packages that can implement it, provided we can supply the data into these engines to do the calculations that we need to then pull back out. So a lot of the pieces are sort of there. We're just putting them together in a way that works. So here's our little recipe for how we build these solutions. First, it's no surprise here, we start talking to people. We don't look at data in the first stage. The first stage is let's build a causal model. And what does that mean? That says, what is it that you're trying to, what event that's happening are you trying to understand? So that event might be a customer leaving. That event might be a shipment, the quality of a shipment and whether they reorder again. And then the knowledge model is all of the information you need in order to do that reasoning. So the causal model is like a reasoning model. Remember, model is just a programmatic way to describe a flow of process or a set of data and how it represents the world. So the causal model is more how the world works. And the knowledge model is more the way the world is. And when you look at the causal model, we're really looking at events, things that have happened in the world and how those chains of things come together to create some value or to create some other new event. The event might be the customer leaves. So what we do at the beginning is we don't even look at data. We just like talk to people that actually understand the business, know how things work, and with them brainstorm through what that initial causal model works. And then we go and find data. We get some historic data. We see which parts of it they already have, and they may have come up with some ideas where they don't even have data for. So we may need to figure out how we're going to source that. So it might be, let's say, when the weather's hot, customers are angry and they, leave. This is an example, but they may not have weather data, but there's web services out there that do. So really, we want to build a solution that can connect to all these data inputs and just wire them into this model. And we're using Node-RED to do that. So I'll show you how that works. So we fill the gaps, then we build the algorithms that implement the effect nodes. This is going to make more sense when I show it, but in the causal model, there's functions basically that all these events go into, and then this function is going to run that's going to figure out which of those inputs, what probability, what kind of effect they have on that outcome. So this is where data science actually does fit in and is a really good place to use it. We're not saying data science bad, causal science good. We're saying causal science good, data science a part of it, but not the whole story. It's like saying to a mathematician, yeah, so you get the idea. So we're implementing this microservices, then we build an ETL layer and a UI layer. This is also a hard piece. On my experience on a lot of past projects, ETL is what kills a lot of these things, unfortunately, either because it's done poorly or they're just using the wrong data. The UI is usually pretty straightforward, but given the solution that we're building, we need to think about ETL and we need to think about a UI. So we've got answers for that, and I'll show you what it looks like. So if this all works, and we've seen that it can, all of this can come together as a full-blown solution. Models are there, ETL is there, and the UI is there. So now it's just a question of combining them, and then there's the whole deployment side of it. So we think we've got that handled through the Node-RED infrastructure. Well, we know we do because it already works. And then there's monitoring the solution. There's things you can run on top of these solutions that monitor how they work. So there's another thing that we'll monitor. It's called Grafana. They're actually having a big conference today, but that's how you can actually monitor these solutions in action. So you can start seeing where there's bottlenecks in the system, maybe what functions aren't running fast enough. But this is how you figure out scale. You need to be able to monitor if you want to be able to scale. Okay, quick little platform architecture. Check my time here. Oh, we better get moving. Okay, platform architecture. So this is not very detailed, but this is kind of the idea. There are a bunch of great machine learning tools out there, TensorFlow, millions of Python libraries, Jupyter notebooks, everyone's got machine learning tools. That area is very saturated with great ideas. So we want to be able to leverage as much of that as possible. We need to store everything in some place, and we need to be able to reason on top of it. And this is where Vatical comes in. So the underlying graph, because we believe graphs are the correct representation for what we're doing in knowledge modeling and causal modeling, and the graphs are most suited for it. So you can do inferencing. So within the Geminos tools, we've got a section here for building a causal model, building a knowledge model. This is sort of our add to it. There's causal calculus and the simulation engine, which we haven't built the simulation engine, but I can talk about how that will work. And then on this side here, this is really the infrastructure. So building the causal nodes using a low-code microservices solution, ETL nodes, user interface nodes. Node-RED, if you don't know anything about Node-RED, Node-RED is basically a way to take existing little tools, things like connecting to AWS or connecting to Alibaba or connecting to TensorFlow and making a node out of it, or writing to a database, or creating a UI. There's these little nodes, little programming blocks that you put in and they do things and you set properties. And so that's what we're doing. We're taking this orchestration framework, connecting together these useful nodes, and there's thousands of them out there. I think last time I checked, there were 3,500 in the published library. So that's kind of how this Node-RED piece fits in, and there's data in the bottom. That historical data hydrates the knowledge model. This is what's happened in the past, and that goes through ETL, but new data may come in through a sensor or may come in through a new database you need to poll every night or every hour or every minute. But being able to bring new data into this, sometimes that's a struggle, being able to stream data into solutions. Again, using a package like Node-RED, you can get around that. So what we want to do is take the data that's coming in, stream it into Node-RED, run that through a transformation in Node-RED and inject it directly into TypeDB. So TypeDB is sitting behind the scenes while we're building programs and solutions on top of it. And just to drive this home, Docker, Kubernetes, this is how the world works today. So everything we deploy, all of these little nodes is running as an image, and we can deploy and orchestrate and bring these back up, and all of the DevOps type of stuff gets handled in here. This is what Jerry does well. Okay, so setting up the problem. 3PL and churn. So third-party logistics, and customers are leaving or shippers are leaving. So in 3PL, they call customers shippers. They're the ones that are sending products. So Acme Rockets, Acme Barbecues, Acme Boats. You can tell I'm a Roadrunner fan. Got Wile E. Coyote here. So what are so these are the customers. What are the things that can happen to them? Prices can get reduced for shipping. The shipment could have a failure. There can be a weather problem. There could be some news about the company. Maybe the decision maker in the company leaves. Claims can be applied against a shipment. Shipments happen, prices go up. So there's all these events, these things that happen, and they're happening too. So these are the events, and these are the entities. These are the things that are happening too. These events can happen to Rockets, barbecue, different customers, or even different carriers. And this is, again, so think of a price, or think of a shipment. A shipment is really, when you think from the Graken or from the Vatical side, a shipment is really an event that happens that involves a customer, a carrier, and a receiver. So we're going to model these events as relationships and these as entities. Once you've done that, then this whole time discussion comes up, and look to the modeler. One of the guys on Discord is named the modeler, and the dude's like really, really smart about how he thinks about time. I'm also fascinated by time, but start thinking about time as this set of events that happen in time. And can you start seeing patterns in these events that are leading to some type of outcome that is either desirable or not desirable? Can you cluster customers based on their event patterns? There's a huge amount of interesting work that actually is quite important when you're doing causal modeling, is understanding the clusters that you need to segment for, so that when you're applying these models to them, you're applying it to the right group, or you're applying the right causal model to the right group. And what that might mean is the causal model for why a customer leaves is probably going to be different based on the cluster that they're in. So if you're a cluster of customers, say that ships rocks, something really hard and very difficult to break, the causal model for why you might leave probably doesn't have anything to do with how often they drop the packages, because it doesn't matter. The packages won't get damaged. Whereas if you're a company that ships like glass chandeliers, your causal model is going to be quite different than the guy that ships rocks, or the company that ships rocks. So understanding how you're segmented also determines what type of causal model. That's sort of just a bit of background. Okay, so that's the background. Now I'm going to jump into how do we build one of these things. So let's make sure this is all working nicely here. Okay, so this is Node-RED, but we're calling it Geminos Cause because we've added stuff to it. So this is the tool that we're using. And it's basically one of these tools that you can drag boxes from your set of what they call them nodes here. So let's say I'm maybe interested in bringing in an IBM Watson model. I've got nodes for Watson. Maybe I want a feed parser, an RSS parser. So I want to bring data in from an RSS feed. I want to parse that RSS feed for maybe the customers that I'm looking at and bring up news related to that customer, because maybe we want to integrate into our causal model news events. So something that comes out in the news about it. So you can bring in a feed parser. Social, you want to bring in those are just email, but there's all these different things. Like these are TensorFlow nodes. And I'll just show you the ones that work. So basically nodes on the left, they do anything and everything, anything you can think of. There's probably a node for it. If there's not, in this case, when we tried to do causality, there were no nodes to do causality. So we had to build them. So this is what we're doing. So here's kind of the model that we follow. Build a causal model about the problem, build a knowledge model of the data in that causal space, build the ETL layer to get data into that knowledge model, build a UI, build your algorithms to do the calculations and the causation, and then identify clusters and build it. In reality, there's a bit of a loop that happens here, because you realize, oh, our causal model is missing something because we ended up getting down to this point and there's still a whole bunch of unexplained effects. So we need to go back and understand. So it is a bit of a loop, but this is the general idea. So let's start with the causal model. I won't go through this whole thing in detail, but I'll kind of give you a high-level summary of it. Let me get this out of the way to get as much screen space as I can. Okay. Ignore the green stuff at the top for now. This is just some updates that we're making. But the first thing that's going to start is, what are you building a model for? So we're building a model to understand when someone churns. So that becomes an event. They leave or they don't leave. So there's something that happens ahead of this. There's a function here that's, so one of the ways I like to think about causality is, there was this thing called the 5 whys. I think it was popularized by Toyota, but it sort of made its way into the business world. And the idea was, in risk management, if you asked why 5 times, you ended up with a root cause. Sort of an idea. It's probably not accurate completely, but it's a good idea. So like an example would be, why did my customer leave? Well, because they left because they went bankrupt. Okay. Or they left because the market changed, COVID hit. Or they left because their perception of you as a shipper changed. Okay, well, why did that change? Why did my perception of you change? Okay, well, let's go into the causes of what might cause a perception change. Well, maybe there's a shipment that happened that had really, they screwed up the shipment, right? So there's a shipment score idea that needs to get created. Or maybe a new salesperson was put on the account and they liked the old one. And they're like, you know what, you took away my best person, I'm going to go find someone else. Or maybe the customer just said, new guy in charge, I want to go with a different company, too bad. I got a better relationship with them. payment issues, maybe they stop paying you, and that should be an indication that their perception of you is changing. They're stopping paying you. That's either their problem or your problem. Or competition is doing something in the world that's getting in your way of doing it. So these are these ideas of events. So each one of these is an event, and this will become, there's a model behind this event. If I double click on one of these, you can start seeing the types of things that we're doing in these events. We'll dig into that in more second in the knowledge model. Going back a little bit further, let's just take this shipment. So let's say there's a shipment that went wrong. Well, we want to understand, why did this shipment go wrong? So we're working backwards in this causation chain. Well, we need to update the shipment score. Well, what updates the shipment score? Well, maybe there's a service issue. So a customer actually filed a complaint against this shipment, or they made a claim. They said, you know what, the insurance on this, you lost my order. I'm going to claim you owe me $1,000. Or let's say it's a COVID vaccine, or it's a biomedical thing, and there's a temperature violation. So how do we get temperature violations? Well, temperature violations are really just events that are happening out in the world on sensors. And why not just wire those sensors up such that when the event happens, we inject it into this model, so we know in real time what's happening on those sensor events. Same with shocks. You've got vibration sensors. So there's all these little sensors out there that can generate events that may update the shipment score. And each one of these things is going to contribute something to this, this calculation. So within these calculations, so how do these calculations work? This is a big piece of this. So there's two ways to do the calculations. I'll show you the easy way. Actually, I'll show you both ways. One is, it's not easier or harder, it's just different. So the first is just a function. So if you double click on one of these things, and this is a really boring function right now, but it is just a framework for it. But here's where you can actually integrate causal engines of your choice. We're going to support some subset of the ones that come out initially, but there's some good Python ones out there. So we could import those. And because we're able to orchestrate all of the flow of information through this model, we can use the compute in here to actually do the causal calculations. And then in this case, this is more just illustrative, but I'm returning the shipper.customer relationship score. So in my model, my knowledge model, which I'll show you, my shipper actually has a customer relationship score. So my entity called shipper has something called customer relationship score. And that score indicates basically how happy the customer is with all of the service they've had up to that point in time. This is where time gets into it, because that may change over time, right? You may want to track the customer relationship score over time, and then all of these causal factors that are also matching this customer relationship score over time. And that is really the solution we're trying to build. So that's the causal model that explains how influence is moving through this system and how these different concepts are coming together into these different functions that are calculating it. Now, this was a simple example. It's just a function, but I can also, within here, I've got this update shipment score. I can double click on it. And this is what's called a subflow template. So I can bring all of these calculations in to a new template. So the input's coming in, and I can start, I can put an LSTM in here, maybe run a TensorFlow calculation to determine the customer cluster. There's a base, like this is an example, this isn't real, but this is the example of what you do. Let's say you want to bring in an IBM Watson model. We can bring in a Watson model, double click on it. And this is what I mean by setting these nodes. This could be, let's say, shipper happiness. Let's say it's something, or let's do something more specific. Shipper satisfaction. Sad, I don't know. So you can configure these things. So these are the different types of connections. So these properties here are specific to IBM, to Watson, in terms of how it does things. So you can get models, you can execute models, but these would all happen on that microservice there. So this is kind of how they're integrating all these different things. So this is an IBM one. We could go in and we could bring in, these ones down here are for Siemens, I believe. So this Siemens released a bunch of, so these are PLCs that you can get from Siemens, and these are the S7 collection. So we can bring in all of those nodes. So there's all these different things we can bring in that connect to different devices and do calculations on them. So that's the causal model. And jumping down into this calculation here, you can decompose these calculations into additional flows. So that's the causal model. The knowledge model, which is I think what most of us are familiar with when we're using Kraken, I should not say that, when we use Vatical. It's difficult to remember the new term, Vatical. So with Vatical, I can go in and model. So here's the model that I built for Vatical for this problem. So we're talking about a causal model. So I need to talk about salespeople, right? These are the people selling the orders. There's shippers out there. These are people that are moving things around. There's carriers. These are the actual people that physically move. Shippers are the ones like Nike or Adidas or Best Buy, or these are the ones that are shipping things. Carriers are who's moving it for them, and recipients are who's actually going to. So these are the entities. So the way you create an entity is just drag it, put it on the chart, double click on it, and you can start filling out different properties. So I can, let's say, want to put some owns in here. Let's say we're going to create a, I don't know, let's say we want to put a truck in here. So we've got a truck entity, and it's going to have a license plate number. We'll make it a string. And let's say mileage. They got mileage, probably spelled that wrong. I'm an absolutely atrocious speller. M-I-L-E-A-G-E probably. Who knows? So that is an entity. It's called a truck. Let's say the truck participates in a shipment. And we could go and modify the shipment. So you're connecting these nodes together. So I'll just show you for the ones we have. So salesperson, name, address, customer relationship score. So this customer relationship score, or sorry, this should be salesperson relationships, salesperson score. So every one of my entities, I like to give a score to, because we may want to score anything. So let's call this salesperson score. Actually, we're already in salesperson. We could just say score. So each one of these entities, shipper, this is the name, address, customer relationship score. So where does this customer relationship score come from? Well, this is what the causal model generates. So the causal model is going to generate an event, whether this person leaves or not, but one of the internal calculations is the customer relationship score and the probability of churn. So those things should come out. Like if you look here at my causal model, coming out of my update, the shipment perception of the 3PL, there's a shipment relationship score coming out. So this is getting written to that entity at a specific time so we might have an array inside that entity of time and the score at each point in time. And then up the churn probability, this should actually say shipper churn probability. Churn. So you can name these whatever you want. So the idea is you fill this out, back to the knowledge model. So the knowledge model is actually informing, or sorry, the causal model is informing this knowledge model for some of these elements in time. Shipment, for example, let's open. So these are the entities. Now we're going to look at the causes. Now I'm calling these causes shipments, service issues, claims, staff changes, interventions, payment, and news. So how did I come up with these? Well, I looked at my causal model and I said, what are the things I need to be able to model so that I can understand what's happening in my world? So things like temperature, shock, service issue, claim, shipment, new salesperson, decision maker, payment issues, competition interventions. So I didn't get all of them in here. Right now I've just put some of them in, but like, where is it? Service issue. There's actually a couple of these. Service issue, they drop packages. Some of them are important and some of them aren't. So being able to really orchestrate which ones are coming in is important. So in order to make this work with Vatical, what I wanted to do was we need to inherit a certain set of properties. So in cause, if you look at that, it's sort of a group. So this is going to inherit a bunch of things like class, type, code, when it started, when it ended, where it started, when it ended, the score of that event, the complexity of that event. So each shipment may have a different complexity index. The shipment, whether it was successful or not, could have a different score. So every one of these causes is going to inherit a set of these properties. Now, within the shipment, what are the things specific to the shipment in addition to the causal stuff? So a shipment's an event that's inheriting the cause, plus the items of the shipment, the cost of the shipment, and maybe from and to. So this is where you can go and build these models. So again, so we've laid this out, we've built this tool to do it, but now we want to be able to actually generate the type QL. So we have this box up here you can click, and then it generates the type QL related to what you've just drawn. So as you change it, unless you'll get different, you even have rules in here. So like shipment sub cause. So there's all the stuff that it owns. It relates to salesperson, relates to shipper, carrier, plays, service distribution. So this is all looks like proper Vatical code. And in fact, you can actually run it. I'm not sure I should share that on the screen. I don't know if it's going to work on Zoom right now, but I could go in. I've actually done that, and I've ran it through the TypeDB schema, and it loads. So that's the first step. That gets you your model. Now you need to hydrate the model. So how do you hydrate the model? Well, you go to the next step and build your ETL. So now we have this ETL layer. So you've built your causal model, you built your knowledge model. Now who cares? Now we want to start pushing data into this thing. We want to make the causal model and the knowledge model actually part of the application. We want this to be part of the fabric of how your application works. So to do that, we're going to bring in and hydrate these models. So there's an initial load, and then, usually most projects, you've got an initial data load, and then you've got an update. That happens every hour. So we'll just take a look at this initial, I'll look at the update, might be a bit more interesting. So each one of these is a subflow. So let's open that subflow. So what does that subflow look like? Well, this is just yet another complicated ETL pipeline, but it works and it updates your TypeDB. So this is the piece we don't have working yet. This is something we're working on right now. But essentially all we're doing here is we're taking inputs from data sources. Let's open up one, update salespeople. So salespeople may come from a file, right? That may be the way you initially start it. Double click on it. So this might be the file here. It comes in, you parse it. So Node-RED has a CSV parser, of course, and you can go in and you can set properties and what you're doing with it. And then you need to format it into Grackle. This is the part I'm working on right now, but we need to take this parse CSV, and we're using Mustache, which is the syntax templating format to, and this isn't the right example. This is just printing them out on the screen as a list, but you get the idea. You can create templates that output valid type QL that does the insert. So that's what this is going to do. And then all we do as a solution developer, we're just going through and we're building out these ETL pipelines to hydrate all of these elements in our model. Like one of the things that's happening, let's open up, let's take financial news. That's another example. Edit this subflow template. So this one I worked on a little bit more. So I want to pull in news from CNBC. So I grab the CNBC RSS feed, and that's bringing in CNBC stuff. And then I want to filter it for certain sets of stories. So maybe jobs and G7. If this is a better example and I had more time to plan it, I probably would put in a bunch of customer names. So for a particular customer, give me the news related to them, then look at that news, determine whether it's an interesting event or not, format and then inject it. And there's lots of sources for events. You could use this other thing called GDELT. I'll just show it to you. This is one of my favorite, absolutely massive databases of events. So these are events that are out there. Every 15 minutes, I think every news story in the world is translated, indexed, and identified for what's going on. So you could connect to the GDELT data set and just return a set of events that are related to the things you care about. So if you're building maybe a solution for, well, there's a lot of, I don't want to get into, give too much away, but if you're building a solution that is needing things that are happening in the world in real time, this is a great place to get it because it's all in one place and it's super well indexed. They've got a very good taxonomy for it. So this could be the source data here for some of these flows. Yeah, so then we're writing it out, and yeah, so that's kind of how this ETL layer works. Let me close a few of these extra things. So we build the ETL layer. I won't dwell on it. ETL is boring, but very hard. And if you do it wrong, it can ruin your project. So we want a way to make sure that ETL doesn't get in the way, and we can leverage as much external data as humanly possible because there's such great data out there right now. No one company really probably has all the data they need to make the decisions that they need to make without using external data. And these pipelines need to support that. The UI is a bit in the air right now. There's a couple of ways we can approach this. First, build the solution, then put a UI on top of it. Well, the quickest way to do that is to, again, use this framework we already have. There's a dashboarding set of nodes that we can use. So buttons, drop-down switches, and you can wire together all of these different elements. So we're bringing in, let's say we want to make a timeline. We bring in these nodes from our model, salespeople, shipper, carriers, or receipts, and we bring in all of these different UI functions, or these different, these different events, and then we organize them all into this timeline UI component. So Node-RED is very good at being able to allow us to build these solutions. So we don't need to go and build all this stuff. It just exists. We know it works. Lots of people use it. A lot of big companies are using Node-RED. It was originally created by IBM. So it's a great tool. It's a really nice tool, and it works well, and it's been around for a long time. It's oddly enough, the main use of Node-RED today seems like for people that are doing home automation systems, like you walk into your house and the lights turn green. Hey, Google, turn the lights blue. Mine might actually do that. But it's one of these things where you can go in and control your house. So this is where Node-RED's really popular, but it can be used for so incredibly much more. And I think that's the future of Node-RED, is it's probably going to be moving more into an enterprise space. So if we can integrate that with a powerful back end like Vatical, there's some very interesting tools, and then you add causality to it, and now you've got a method for being able to really build some interesting and exciting solutions. One other thing I probably should show here, because this is the Vatical talk, I'm going to open up, say, a shipment. I just want to show you some of these screens. So here's a shipment. This is probably our most complex thing. Items, cost, from, and to. Well, it also relates things: salesperson, shipper, carrier, receipt, plays. So this is the part where it needs a bit more love. Right now, you actually have to type this stuff in. Ideally, as you draw these lines, these should just auto-populate, because all you're doing here is you're saying, okay, what is the thing I'm connecting to, the service, and then what's the item? It's called a shipment. I'm making a claim, shipment. So this could all be automatically generated. Right now, we're just making sure that we can actually generate valid type QL, and then we'll start improving these things. So this is kind of where we are with the solution right now. We're really interested in working with people that can help us understand what's missing. And this is the great thing about this is, there's so many people thinking about this. If we can get it in the hands of a few people to start playing with it, it's not perfect yet, but it's getting to the point where we can probably start building some very nice solutions. Yeah, so that's sort of where we are. With the causal model, that's really something that you'd want to sit down with a customer and understand how you're approaching their problem. And I think that's what's unique about the value proposition Geminos has over a lot of the other clients, companies that are out there that are offering data science, is we're really offering it from the perspective of causation and events. So causation is this, this flow of logic, and events are the things inside the flow, and the model is the thing that underpins the whole thing. So this is what we're up to. It's a lot of fun, and we've got some really interesting people we're talking to, and we're really figuring this out with the community. And I think Vatical's the perfect back end for this, for the store side, because there's so much inferencing power. I suspect we're going to be building models, and let's say you build one and it's very successful, and the customer says, you know what, I loved what you did with my shipping problem. Now I'm really worried about my carriers. I need to figure out which carriers are giving me the most problems, because it turns out that those carriers are screwing up a bunch of shipments. So now I need this concept of carrier score. Should I fire this carrier, keep this carrier? So, well, okay, let's build a causal model to understand that particular carrier and whether we should follow it or not. I see there's 29. I bet there's 29 chats. I have no idea what's happening in here, so I apologize. I just sometimes get wrapped up in things, but I'm going to at least pause here because we have 9 minutes, and it probably would be a great idea to open it up for some questions and answer something.
Well, first of all, well done, Jeff. Excellent talk. This is just, from personally, I think this is extremely cool and impressive what you all have built. So jumping right into the some of the questions that were asked. And this also is an opportunity for, as we sort of try and model the live meetup experience, where we have the open mic at the end. Please feel free to raise your hand in Zoom, and that way we can bring you off of mute and you can share ideas, thoughts, feedback, questions, and that way as well. And to start us off, Adam, you had asked a question earlier on, and then I believe had another one as well. Do you want to come off of mute and share with Jeff and the rest of the group? If you'd let me know by just hitting the raise hand button. Beautiful.
Cool, this works.
There you go. Adam, hey.
Hi, thanks a lot for having this talk and the interesting group. I've got a lot of new bookmarks, so that's always exciting. I'll spend some time exploring those. Jeff, thanks very much for the interesting talk. I've been interested in causal reasoning, so it's great to see how this is branching out into things. And I think that I can kind of connect two of my points. One is that the way that you create causal relations is basically human engineering. You say to, at least as you presented it, as you said to somebody, you know, you have this problem and what do you think are the causes of this? And they may give you a variety of factors. So the discovery procedure for the causal relation is really human interview. Okay, so that actually already answers, if you agree with that, that answers the question.
I think it depends on the domain a little bit. If it's a domain where there really is a lot of actual data where you can calculate, like if it's a domain where you have a huge amount of data and you're really just looking for correlations, and sometimes those correlations are in a closed enough system. Like let's say you had a physics model and you're looking at gravity. Like I think there's some very toy worlds, and a lot of the research science sometimes is a toy world. The models are so designed to that world. I'm used to more like messy worlds, like people and companies and events. So I think the way we're approaching it probably works better for enterprises, but may not work well for hardcore, say, research science where you actually are. Yeah, I'm guessing there. I'm not an expert.
Yeah, it's not. It didn't sound to me like it's a data mining activity, because even though sometimes you refer to, you know, inferring causal relations from patterns of events, as you go over the course of your presentation, you don't do it that way whatsoever. So if I could just exploit my opportunity right here, because there's a related question that I raised later. So once you've established this causal relationship, so you have some effect essentially, and then you have a variety of things that you're calling the causes, and you say a lot of these things may have a weight, or maybe they have a Boolean. And then I was thinking, what you didn't explain, I'd be interested in hearing your thoughts about this, is how do you do the calculation from those input causal elements or factors to the output causal effect? Did you have some thoughts about that?
Yeah, and I didn't really dwell on it, but there are existing we're really not going to build a Python library that does causation, because it's already, there's other ones that are there. And I think we want to integrate with whatever the best tool for doing causation is, and that'll probably change as time goes by. So we're really looking at it, how do we integrate the best of breed tools? So in those functions, and actually let me just kind of show you what I'm saying here to make it a bit more explicit. So in this causal model,
that's exactly the point. And that was it. So you put something in for that function, depending on which sort of, you know, library that you want to be exploiting, and it'll do some kind of calculation over the causes. Okay.
Yeah, so we can control the data going into the function, and then there's this function that's doing the causal inferencing that we can essentially import. If there, well, we know there's causal libraries out there, and I think this is another sort of computer thing. If you're building solutions today, don't try to create anything from scratch. There's such great stuff there, just integrate it. So for the causal engine, we're just going to integrate with a really, we'll actually leave it open, because you may have 3 or 4 different causal libraries you want to use.
Okay, thank you very much for that. That helps me.
For sure, for sure. Thanks for your question.
Thank you so much, Adam. I'm much appreciated for sharing your thoughts and questions here. And in I've sort of lost the order by which they were asked, but Fike, Thomas, and Ivan, I believe you three had questions. So whoever raises their hand first, I'll bring up of mute, and you can ask your question, share your thought or feedback. I think there were some good ones. Otherwise, I can read the questions out loud from the chat, which I will bring up here. So Fika asks, it looks like the current causal model contains all kinds of functions as long as it is a calculation or a flow. Can it handle uncertain knowledge or contradicting knowledge when you are still not sure whether your causal knowledge is correct or not?
Yeah, you can design. It doesn't prevent you from designing bad causal models. I think that might.
Hey, Fika. Hello.
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 Does it work?
We can hear
yes,
you.
Thank you for your interesting talk.
Thank you.
So yeah, I was wondering if you look like if you're not sure about your causal model yet, can you then still implement it and make it work and do the calculations? And how do you encode it in your model? Because then you have to, maybe there's contradicting knowledge, or you have to add something like a chance that it's correct, or.
Yeah, that's a really good question. The short answer is, it's right when it works. The long answer is, like when I showed that little cycle of things that you do, you don't build, usually what we've found is when we build a causal model, the first pass misses a lot. You get to the end and it's not doing a very good job of predicting some event that you want. So the first pass is sort of the talking to people, and then you start digging into why isn't it working? What's going wrong with this model? What are the events that potentially are missing? Because we can see a certain amount of the effect is unaccounted for. So that's when you need to start asking more questions, maybe looking at other correlations that you're seeing that aren't being represented in the current model, or you're just talking to the wrong people, or there's an effect that's happening that you just haven't figured out. Like, a good causal model emerges from, I believe, at least in a lot of the spaces I work in, it emerges from experts that know how things work, supplemented with a lot of data about how things actually are working. Like in oil and gas, we used to talk about tribal knowledge. And what that meant was our group of people in our company was the tribe, and we had a set of knowledge, and that was really how things worked, what happened, and it was often incorrect. Tribal knowledge will only get you so far, because real like an event like a well exploding in the oil field would be a big deal, and that would really imprint into a lot of people's models certain things not to do. When bad things happen, we tend to give them too much power, too much causal power, when the actual effect's much lower. So just relying on people is a bad idea for everything, but it does at least help you understand what are the possible relationships, just knowing that there's going to be a lot of bias in how people come up with stories to explain why something's happening. Because really, this is all the causal model is a story which explains why, right? So if your storyteller is a person that is missing a part of the story they're telling isn't going to make sense. It's not going to explain something. So, we don't actually, like, we let you draw bad stories, but we also allow you to see that your story is not making sense because it's not predicting some event.
Do you think your machine learning model, or your whole pipeline then can predict kind of which action to take, or which variable to take a look at again? Or for example, if you have a robot, then you can even do actions in your world. So maybe
now you got it.
You can perform some action, and then if your whole model can tell what you should do or what you should examine, then it would be interesting.
And you've hit the nail on the head, because what you've just said, I think, is the next step. The next step is, you've got a model that and Node-RED, right? One of the reasons we chose Node-RED is because it can actually control things through Node-RED. Like, you can turn lights on, you can turn, like in houses and all of these things, you can control systems. So why not build a causal model that actually has control pieces in it, that controls your machines, your PLCs, it can control pipelines. Like, you could literally have an entire system that's being controlled from a causal model. it's making a prediction and it's saying, hey, this pipeline is going to hit a certain capacity. The causal model can say, I'm predicting to a 98% probability this is going to happen. I'm going to create a new event called divert this stream of oil to this other pipeline. So you could create this model that's actually shipping and changing what's happening in the physical world. Then you can measure it because you've got the data coming in, and you can say, was this the right event to have created? So you can start testing you can start testing counterfactuals. You can start building a simulation engine that's not even a simulation engine. You can build an engine that's monitoring and working with the real world. So I think that's like a really impressive solution, is going to also not only calculate what should happen, but actually do it, like make the change in the physical world. So that, like, we talk a lot about virtual worlds and how do we from mirror worlds. You have there's this big effort right now called digital transformation. And really, it's taking these physical companies and transforming them into these digital enterprises that make decisions based on the information backbone. So this causal model is a way of approaching how we can make decisions in this enterprise decision-making environment, where there's literally hundreds of thousands of decisions every day that need to be made by people that aren't making them with the right information. So can we hook these causal models directly into this Internet of Things infrastructure? Again, this is why we chose Node-RED, because that's what it does. And this is why we think it's so important that enterprises, focus on these types of, the causal models is important, but being able to actually control their whole infrastructure, like their SCADA systems and their PLCs and all of the control systems that make the world turn. Yeah, we're after that.
Thank you so much, Fike, for asking those and sharing those thoughts. Thomas or Michael Sullivan or Ivan, would you like to share thoughts off mic? Otherwise, I am happy to share your comment in the chat. Let me just pull it up here. So Ivan asks, what about knowledge abstract that's common in structure across industries or sciences?
So knowledge abstract? Things like
maybe common knowledge models.
Oh yeah, yeah. Oh, good question. Yeah. No, there's like, so actually I didn't show that. I'll show you this. So one of the other things is nice. We can go in and do things like projects, open. Continue. So this is just an example of a few things. So you can have different models in projects. So we're behind the scenes, each one of these projects is just a different set of flows that are happening. So here's a customer churn, here's a pricing prediction use case. And each one of these different use cases can do different types of causal models. So if you want to be able to share things, like you could have a project template, for example. So let me just open the project template, starts off, and right now I think it's just a copy of, it's just a copy of this one. But you could have a different type of model that you could import, and it can become a subflow. Like I could bring in a subflow, say for calculating customer relationship score. So reusing elements is really important. And the way Node-RED is handling this is every one of these projects is basically able to connect to a GitHub repository. So you can, so you can have versions of these projects. So we don't need to invent all this again, right? It already exists, just uses things that are already there. So we can integrate with, say, GitHub, and we could have a published set of models for different industries, or your organization could have a published set of internal models that you don't want to share with the outside world because they're proprietary. All of this stuff can be run. I come from a big industry where we don't like to use the cloud. So we want to hide everything behind firewalls and racks of servers. So all of this internal secret information literally can exist on your on-prem. Even with the GitHub, I think you can deploy a version of GitHub internally. So in terms of reuse, absolutely, you can integrate with GitHub and just publish models to it. We might even have a public set of models that are out there. Sky's the limit. Time and money, right?
Absolutely. Thank you for that question, Ivan. Let's see here. Michael Sullivan, you've got a couple comments in here. Do you want to come off mute and ask them those yourself? Otherwise, I'm just going through here. Let's see, Thomas asks, if I'm correct, we could take the output of a Goldratt theory of constraints current reality tree and use to see the causal graph.
That's an excellent question, but I don't know the answer. I don't know what the Goldratt tree is.
That's totally fair. I think it would be wonderful if you, Thomas, you were able to drop that into Discord with some more information. That way we could continue the chat there.
Yeah,
oh, go ahead, Jeff.
Yeah, no, yeah, please, if there's something I can't answer, put it in Discord and we'll attempt to get someone smarter than myself to help us.
And then Michael Sullivan asks here, how do you, and Jerry chimed in the chat, but how do you allow for man-in-the-middle decisions in this flow, e.g. nuclear reactor?
Oh, interesting question. Yeah. I would love to see what Jerry said, but I'm pretty sure we can create events that allow intervention into flows. So you may, let's say, a shut-off event. You could have the ability for human override could be a node in the model. I don't know. Jerry might have a better answer. Hey, Jerry, are you there? You can come off mute and talk.
Yeah, Jerry, if you'd like to, I'm happy to bring you off. Otherwise, I'm going to, let's see, Michael's got last somewhat related question. How do you wrap a decision in a transaction?
Like in the sense of Vatical transaction?
Presumably.
Yeah, let me think about that. So when I went into decision, I wonder what you mean by a decision. Because to me, a decision is an event. You've made some decision and you do something. So the decision is a new event that should show up in the system. If you've connected your input correctly, that decision should manifest as an event that comes in and should get represented in the graph. So actions you take or decisions you make correspond to events happening in the physical world that we then read in, and the model updates based on those actions that you've taken. So, and unless it's like an override decision, if you're overriding, so the model's saying, turn off the reactor, and the person's like, no, you idiot, you're wrong. That's just good system design. You got to make sure there's ways that you've built in the necessary overrides into these models if you don't trust them.
And the first thing I generally ask is a decision immutable? Because there's different ways you would deal with that particular problem.
It's Jerry, everybody. Hello, Jerry. Nice to hear you again. We've never met, by the way. We're a COVID company. I don't think he's an algorithm anymore because his answers are pretty good. He's passed the Turing test.
Michael adds thinking rollback.
Rollbacks, yeah.
Oh, yeah. Okay. Jerry.
I mean, right off the bat, I don't have an immediate answer. I mean, the idea of, for one thing, I would use typical journaling mechanisms to do a rollback. So, right. I mean, you are on these flows, there would be the ability to, as you're progressing through the graph, as an example, we generally journal your path, so that if you needed to actually take a branch and roll back, you could. And we don't have that model today in the existing interfaces that we're building in Node-RED, but these are the types of things I love to hear, because it allows me to think through to think through how we would actually execute that in the form of the paradigm that we're using. So that's very helpful, and I appreciate that that example actually.
Yeah, and again, this is why we're doing this so much, is
Yeah.
we want
Yeah,
to
I mean, we really do appreciate the opportunity to present to the community this way. You know, we've spent you know, some decent time inside of TypeDB, and you know, we've played around with our own concepts of how we might utilize certain aspects of this. What we really wanted to get from the community, if we can, is really the feedback on, because there hasn't, we don't know or haven't seen any type of, you know, GUI based modeling environment for TypeDB. And I mean, that's not solely what this is meant to do, but we do want to accomplish, you know, the job of producing a UI that is capable of allowing mere mortals to basically instantiate, change, modify either existing TypeDB models or create brand new ones. And then basically we're layering the causality aspects on top of that with knowledge graphs and obviously causal graphs. So, but we would really love to hear from TypeDB community in regards to, you know, what have we missed? I mean, and I love the man in the middle issues. I mean, these are, that touches on a number of different things, especially on the transactional front. So I appreciate that question.
and even like with the community out there, just being able to get access to you know, different ideas of how, you know, the types of things we should integrate into this. Like we're not experts on TypeDB, but it would be really cool, you know, when we start going through this, I want to be able to import schema. So not just create it, but like, okay, you've already got a project going, it's already going well, you've already built your schema, okay, give it to us, let's import it. And boom, now we can see it. Now we can interact with it. We can hydrate it. We can do all of that stuff around it. So I wanted to show that today, but we don't have it working yet, the import functionality.
We do have we do have, you know, just kind of a roadmap scenario here. You know, we do plan on allowing for and building a conditional mechanism inside of Node-RED in the views that are very specific. So i.e. the knowledge model, where, you know, we're going to try to build some constraint mechanisms so that you can't poorly model, you know, a knowledge graph. So we are going to be doing that in some of these views, so that if you know, misconnect, you know, two nodes that shouldn't be connected for one reason or another, you're going to see that, or can't group things together. So we will be working on, you know, making sure that valid schema is ultimately produced from these things as best we can.
Yeah,
Absolutely.
We're not experts, but we hope to work with some.
Yes.
So I want to get to one of the question from the Q&A, and this is about Geminos in general. So Yuri asks, and I'm quoting here, maybe it's me, but what does Geminos do? If everything is done by the causal engine that Jeff said is out there, Geminos does allow to chain multiple models together, but what else? Is there something that I'm missing?
What does Geminos do? Well, we build the infrastructure for being able to build these solutions. We help some of our clients organize their problems around causal models so that we can help them see, is causation and causality a useful technique for them to be able to use? And a lot of times they don't have a background in causal science. Most of the customers we've talked to maybe have read a little bit about it. So part of it is essentially consulting around these models, understanding how it works. But we want to basically build a tool set that anyone doing causal modeling can pick up and use. So what Geminos does right now is we're integrating a set of third-party tools together into something that can solve causal problems. So Vatical's a piece of that, Node-RED's a piece of that. We've got to build extensions to Node-RED. We've got to come up with a methodology for how you approach these problems and make it repeatable and measurable, such that clients that are hiring Geminos to do solutions for them can be assured that, you know, the resulting solutions can be supported and maintained, and these are things that can run. So we're figuring that out, but we're a young company, so we're, you know, also aware that we probably haven't made all the right choices, but we're flexible enough to, I think, modify if something's not working.
Yeah, I mean, we've talked a lot. Obviously, causality is a big focus of what Geminos is doing. Just from a historical standpoint, Geminos Stewart founded an accelerator a few years back that actually spawned 20 plus AI-based companies. Jeff worked for one called Mana. I actually founded one called Ping Things. So our backgrounds have been primarily around artificial intelligence and how do you bring machine learning and analytics to the enterprise in a lot of different verticals. So our what we plan on, what our attempts to do in Geminos are really, there is going to be intellectual property, and that IP, what we're going to bring to the game is some of that experience that we've had in a lot of the verticals that we've played in, and create AI model frameworks that we're going to bring to bear on specific problems. The great example right now is the current 3PL one, where we're dealing with churn, which is a very difficult problem. This is not like cell phone, where you can easily figure out why somebody's churning your cell phone plan. This is a much more difficult problem to solve, and it's one that we've been diligently working on for quite some time now. So we will be bringing that kind of IP to the game, and we were going to be bringing new extensions and new integrations to Node-RED that currently don't exist. Some of that is going to be a set of microservices that we are building that will have associative nodes in Node-RED that allow you to quickly dispatch causal requirements to the back-end microservices and get the results you expect. So.
And wiring that infrastructure of the back end back into the causal structures. Like the causal structures on their own are like academic ivory towers. Unless that causal structure actually controls and interacts with the physical environment, you're just helping people come up with an answer. So the tooling we're putting in there is going to allow that connection back to those underlying control systems.
And to answer Thomas, who just actually pushed something into the chat, we will be providing the causal nodes, the TypeDB modeling nodes, back into the Node-RED community. That is going to happen. We are actively talking with Nick Leary, who is the author of Node-RED. He is the creator of Node-RED, who's now created his, come out of, they've been in, Node-RED was developed in IBM for 20 plus years. It's now, Nick has now left and started his own company called FlowForge. And we are actively working with the FlowForge community and the developers and Nick himself, and have bounced these concepts off of him, because this is a bit of a departure for Node-RED. I mean, there's lots of integrations, but using the actual Node-RED flow paradigm and the way you build to do something like what we're doing with knowledge graphs and causal graphs is something that he had not thought of. So extending this paradigm to support these new ways of stringing things together, we're hoping to get a lot of support from both the Node-RED community itself, as obviously the TypeDB community. I mean, so we're really looking for a collaborative effort, and if we can be the glue that brings that together, we're happy to do that.
Yeah.
Love it. And want to make sure, maybe the last question for today from Brian. He asks, can the system inform the modeler? Is there assistance that is provided to the modeler to build the model, or does the human primarily responsible for building?
Yeah, we're thinking about that actually. We bounced a few ideas out there. I mean, one of the ones that we definitely want to attempt to bite off as we've been going down this path is the ability to reverse an existing TypeDB schema into our tool. So we should, at some point be able to parse an existing TypeDB schema and actually create these flows on the fly. At least we're going to be attempting to do that. It's something much further down our roadmap, but it is something that we want to do. And if anybody wants to float us their schemas, we'll take them and archive them and see what we can do with them. So it is something that we plan on doing fairly soon. Right now, we're concentrating on Node-RED to TypeDB, not the other way around.